So in Fresnel's biprism, we have a thin prism like this. And we have a screen. This distance is given by B, and this source is again at S. This has angle of prism as A, and the refractive index of the prism is mu. So what happens here? Here what happens is, light is incident on the first half of the prism, light is incident on the second half of the prism. Now light after incident from the first half of the prism gets totally internally reflected, and it comes out like this from this part. It strikes like this, it comes out from here. Now, so this angle is my angle of deviation. Similarly, for the second half, the same thing happens. Strikes like this, it comes out like this. This angle is angle of deviation. So I get my two virtual sources as S1 and S2 like this. So for the screen, light appears to come as if from S1 and S2. Now in this case, what is the deviation? D. Deviation you can write as A times mu minus 1, as we had discussed. For thin prisms, we can write the deviation as A mu minus 1. Now in this case, I give this as your homework to find this D. This distance is given as A. So what is the distance between the source and the screens? Capital D. Find this capital D also. And then the last question is find the total width of the fringe. Find this total width. In this case, again, what will happen? For the waves which get refracted from this first half will lie in this region, and the waves which get refracted from the second half will lie in this region. Yeah. So this is my portion. This is my portion where I get my interference pattern. So what is the total width of the prism? I give this as your homework to find this. The answer, by the way, is 2 times B mu minus 1. Similarly, what is small d? Small d is nothing but 2 times A mu minus 1. And what is capital D? It's simply A plus B. Now, for a hint, what I'll do is, I'll show you how to find this small d. See here, this distance is, let's say, d by 2, and this is A. So you can write d by 2 A is equal to tan of delta, or my ds to A delta. So now I put the value of delta, that is A mu minus 1. So I get ds to A mu minus 1, which is the answer. To figure out this, geometrically you can prove that this angle, by the way, is 2 delta, right? So when this angle is 2 delta, I can say that this total width is 2b delta, or 2b delta I can write as A times mu minus 1. Okay. Okay.